Let's go to page 234. This is lesson 4.3, and this lesson is to prove triangle congruent by SSS. Now the S stands for the side of a triangle, so SSS means side, side, side. Okay. So let's go over the postulate. It says side, side, side congruence postulate. It says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Now make sure you match up the sides carefully. So you go by the hash mark. So one hash mark match with one hash mark. Two hash marks match with the two. Three match with the three. So what it's saying is that the AB is congruent to RS, and BC is congruent to ST, and AC is congruent to RT. Okay, so if the three sides are congruent to three sides of the other triangle, then the triangles are congruent. So that's called the side, 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 or the SSS postulate. Okay, so here's an example one how to use postulate. So normally they will give you two information. Then you have to look at the picture to get a third one, because you need to get three congruents to prove the triangles are congruent. Okay, so over here, it's important to draw the picture and do the markings. So given KL is congruent to NL, so KL is congruent to NL. So make sure you do the hash mark. Okay, so this is congruent to that. The second one, KM is congruent to NM. And watch the order of the letters, so make sure you match carefully. And that's the second hash mark, right? So again, normally they give you the two. Then you have to look for the third one. Now, when you have triangles like side by side, you have to use a reflexive. Notice LM, see over here, or KL, not LM. So LM equal to LM, right? This is equal to itself. So you can put a three hash marks over here. So now you have a side, 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 you got S, S, S. Okay? So therefore, the triangle KLM is congruent to triangle NLM. Again, make sure you match the order of the letters carefully. So this is three hash marks. So when you do this, right, again, because reflexive over here, so you can put three hash marks over here. Okay. So when you're doing the letter, notice the K is facing the three hash mark, so it will match with letter N. Okay. Then L, okay, L is facing the two hash marks, so it would match with L facing the two hash marks. For this triangle, the M is facing the one hash mark, and so M we're facing the one hash mark. So make sure you match up letters carefully. Okay. Okay, let's go to example 2. It says which are the coordinates of the vertices of a triangle congruent to triangle PQR. Okay. Now notice so what you need to do is you have to look at the side. Okay. And basically what you do is, one way you can do it is you can figure out all the sides, okay, on each one, or you can just plot that on a graph paper. It kind of really shows you. It's more obvious if you do on a graph paper. So let's go and do that on the graph paper. Okay, so our original one is right over here, and go 1, 2, 3, and go 1, 2, 3, 4. Okay, so this side is 3, this is size 4, and use your Pythagorean theorem, a squared plus b squared, so it'd be 9 plus 16, give you 25, take the square root, you get 5. So this is very common spatial triangle, so make sure you remember the 3, 4, 5 spatial triangle. Okay, so this is P, Q, R. Okay, so now let's go and plot the other ones. So you got negative 1, 1, and you got negative 1, 5, okay, and -4, 5. So again, if you count the square, this is 1, 2, 3, and count the square 1, so it's 1, 2, 3, 4. So you can notice 3, 4, this would be 5. So right away, the answer is A. Okay, so A is the correct answer. Now, if you don't believe that, you can go and do the rest of them, and you can see that they are not going to be the same. So again, so this match with that, this match with this match with that. So it'd be SSS congruence. Okay. Okay, let's go to page 236. Example 3, solve a real-world problem. Structural support. Explain why the bench with a diagonal support is stable, why the one without a support can collapse. Okay, the reason for that is because, see, if there's no support, it can move. So this one can slide over and it collapse. Okay? Where its triangle is rigid, okay, it's because it's SSS, right? So basically you apply the SSS theorem or partially in the real life. So whenever a triangle is stable, whenever you have a rectangle, when you have 4 points, it's unstable. Okay? So if you look on this one over here, so determine whether the figure is stable, explain your reasoning. Okay? So this is not stable because this thing can move. Okay? Because again, there are four joints. So this can kind of push against each other and it becomes like, you know, a collapse, or it can become like a rhombus. Okay? So this is unstable. This one, whenever you see triangle, is stable. Okay? Because triangle cannot be moved. Okay? So this is stable. This one is unstable. This part is stable, but this part is unstable because if you push really hard over here, this thing's going to kind of collapse this way. Okay? So again, whenever you see triangle, it's stable. When you don't see a triangle like rectangle or like quadrilateral, then it's unstable. And that's why if you look at like a bridge, you can see a lot of triangle. There's a reason for that. Okay? On the bridge, there's the support. You see a lot of triangle configurations. It's because triangles are stable and it's very strong.